So there's going to be these two postconditions, one having to do with the new link in the association, and the other one having to do with contingently updating the request list. So we'll consider the first postcondition here. What we're really saying is that there's going to be a new checkout record. Another way of saying that is there must exist a new checkout record, and in fact there's a keyword in OCL called exists. And so the postcondition here is going to say there's going to exist, and this is just like in our first order logic where we had the leftward facing capital letter E, that there's a bound variable, in this case we'll call it C, so there's a new link in that association, the association's name checked out, okay, with the properties that that link's loanable item had better be the item we're checking out, which was the argument to the operation, okay? And the properties that we wish to hold about that checkout, that is the due date, okay, had better be correct. And to get the due date, we can go get today's date, and then we can add in the checkout period. And remember, we have the checkout period. That was one of the first requirements we dealt with in OCL. And we can go get that checkout period by navigating from the checkout link to the corresponding loanable item and then getting its checkout period. Okay, and the third, so that says there must exist this new item, and it had also better be the case that the checked out association itself must have a new item in it. And the way we do that in either first order logic or in OCL is to make a statement of equality between the state that existed before the checkout operation and the state that existed afterwards. So the state that exists afterwards is just checked out. We can think of that as a set of records or a set of links. But we need some special notation to deal with the state of the checked out association beforehand. And OCL has a keyword called, it's indicated by the @ sign followed by the word pre. So this is saying checkout at pre means the version before we call the operation, and checkout by itself means the version afterwards. And there is an operation on sets, and checked out is a set, it's a set of links, okay, that allows us to indicate that another element is associated with that particular set, and that keyword is including. So it's as if we are constructing a new set, which is the old set, plus this one new item, actually this one new checked out link, which we've given the name C. So we have the checked out afterwards is equal to the checked out before and this one other item which we've just added. And that's what's being expressed on the bottom line there. So we're making use of some special keywords and operations in the OCL language to express the equality of these two states.
So I've got a quick question. Can we also consider the at pre including kind of be like set union? So we're unioning the set of all of our checked out associations plus this new checked out association.
Almost.
Okay.
But this item, this new checked out link is not a set. It's just an element. So,
right.
Okay. If we had somehow been able to wrap it in some set thing, then it would be union.
Containing this new element.
And what what I think Jared is pointing out here is that we have to be careful in getting the data types right in these things. So a set is different than an element. Mm-hmm. And if you had a union operation, you couldn't put an element on it. And if you had including, you couldn't put a set on it. So that was the first postcondition having to do with updating the checked out association. The second one had to do with the requests, the list of requests that were made. And we had a precondition that said that if there are requests there, it had better be the case that Jared is the person doing the requesting. So now we need to update that request list if it exists, and with the fact that we want to take Jared off that list. We don't want him to hog the book too long. So in this case, the postcondition is going to make use of another feature of OCL called the let expression. And the let expression is just an abbreviation. It allows us to state in one place an expression and then use it in several places. So in this case, we're saying let the new variable t of type title be that title of the current item. Recall that we distinguish between items, which are things that could be checked out, from the things that could be requested, which we called titles. But an item always has a title. That's the composition operator that we see in the diagram. And we just want to use the shorthand of t for item.title to save ourselves, a few characters every time we type. So the let expression there defines the new symbol and binds it during the scope of another expression, which is the postcondition. And the postcondition here is a conditional as we expected. So if that particular title has a request to this particular patron, and then we want to update the request association. So the antecedent of the conditional is t.request.patron, and if we didn't have t, we'd have i.title.request.patron. There'd be either 3 or 4 steps in the chain of qualified name, and includes is a operation on that set of requests, and self is the OCL keyword corresponding to the instance of the particular class. And remember, that was way back with patron. So we're seeing whether or not Jared is in the list of people doing the requesting. And if so, we want to do another one of these statements of equality between the state before and the state afterwards. So the state afterwards is the requests association, and the state before is requests at pre. And in this case, it's not that we're adding in a new record, it's we want to remove it. But it's a statement of equality, so we're stating that by saying if we, and the keyword in OCL is reject, okay, if we reject that particular, those particular items in the list which have the following Boolean, and the Boolean is the title is t and the patron is self, okay, then we have a version of the request association without that one record in it, and that had better equal to the one afterwards. If there were no request with Jared at the top of the list, then our result is true. Okay, so we don't have to be concerned there. So the overall postcondition constraint has the form of the let binding, and then within that a conditional. And the conditional, we're only interested in the then part of it, which is qualified by whether or not Jared has done the requesting, and in which case we want to ensure that Jared's request is no longer in that particular association.
So do you have a recommendation? It seems like on this if-then statement, because this if-then statement, the else is kind of a vacuously true situation, so wouldn't it just be better to use an imply statement to save yourself some writing?
Good point. So yeah, we could shorten the situation by doing the implies.
I had one other question,
Sure.
if that's all right. So to me, I guess, are all associations that are modeled in our UM diagram, can they be thought of when we're expressing things in OCL as sets? Because it seems like we express t.request.patron, this is an association. We're talking about the patron part of the association, the set of all patrons that have requested things, or in which a request instance is there, is modeled in a set.
Okay, so you can think of them as sets, but sometimes we can do a little bit better. Mm-hmm. So recall that in UML there's the ability to order things, and order things, then we get sequences. Mm-hmm. Okay, so sequences give us a little more power because we can index into them.
Okay.
Whereas with sets, you can't index into them, right? So now a sequence is a set, but a sequence, because it has this ordering with it, allows us a little more power.
And that's going to be based on the model that we have, whether it be modeled that way or as a set.
The properties, the requirements, and whether we modeled it that way.
Okay.